Go ahead and finish off our discussion of proteins by first returning to the amino acids. All right, we've seen this slide once before, but I want you to test yourself. Right, we know amino acids are the monomers of a polypeptide or a protein. How is an amino acid structured? Not only how is it structured, and I want you to draw a structural formula for a general amino acid and use the capital letter R as the variable group. I want you to circle the two defining functional groups on the amino acid and name them. So go ahead and click pause in the video right now. Take the time to do that, and then when you start it up again, I'll show you what an amino acid looks like. I'll remind you. Okay, presumably you paused the video, you tried drawing an amino acid, and I bet it looks exactly like this, right? We've got our NH2 amino group on the left. We've got our central carbon in the middle, got our carboxyl COOH group on the right. The third position off that central carbon is a hydrogen, and the fourth bond off that central carbon is our variable R group. Hopefully you're all able to get that. Now let's take a quick look at what happens to an amino acid under both acidic and alkaline conditions. Now keep in mind that under acidic conditions there's an excess of available protons, H+ ions floating around. How would that impact those two functional groups? So again, click pause and try to modify your sketch of an amino acid to reflect what it would look like under acidic conditions where there's a surplus of H+ ions. Okay, go ahead and pause it. Okay, we're back. Hopefully you came up with something like this. Although we said that nitrogen, according to the octet rule, is satisfied with 3 covalent bonds, it has a little flexibility. It can pick up a fourth bond only with hydrogen and only under acidic conditions. And when it does that, it takes on a positive ionic charge because of the nature of that proton. So the amino group gets protonated, and our carboxyl group stays exactly as it is. The amino group gets protonated, and the carboxyl group stays exactly as it is. Did you get that right? I bet you did. All right, now I want you to pause the video and try sketching the amino acid under alkaline or basic conditions. Remember, alkaline conditions means there's a deficit of H+ ions. What's this amino acid molecule going to look like when there are very few H+ ions to be had? Go ahead and click pause and give it your best shot. Okay, did it look something like this? Your amino group, to be stable, needs its 3 bonds around it, so it won't be protonated with the positive charge, but it'll be a typical amino group. Your carboxyl group now will have been deprotonated. It will have lost a proton. Remember, there's a deficit of protons in the solution, and so what that means is that there's going to be a tendency for any acidic group to donate a proton. Why is this particularly acidic? Well, your normal hydroxyl group is not going to release a proton. Your normal hydroxyl group, that hydrogen is bound pretty tightly. But a carboxyl group's unique in that you've got this hydroxyl. Where's my pointer? It went away. You've got this hydroxyl group connected to a carbonyl carbon. And remember, oxygen's an electron hog in both cases. The electrons now are sharing time between this oxygen and this oxygen. It's essentially an even stronger force pulling those electrons away from the hydrogen. And the hydrogen that was here is very weakly held onto. And so it's readily lost when there's a deficit of protons around. This is why carboxyl groups create the category of organic compounds we call carboxylic acids. These are weak organic acids. They can donate a proton under neutral to alkaline conditions. All right, so take some time to review these things, to sketch them up. Make sure you can do it from memory. Make sure you understand, not just memorize, but understand what's going on to these two functional groups under acidic, neutral, and alkaline conditions. In the meantime, I'm going to go ahead and try to figure out how to turn this off again, and then and you guys are good to go.